Good evening, students. Now I'm going to teach you the horspool algorithm for input enhancement. See, it uses the main concept of input enhancement in string matching. So, string matching is, that how we match the string in the Boyer-Murray all methods and all. So, here in this horspool method, what we do is we take a particular string. Okay, so we have to take a particular pattern string, just match it. Okay, you have to map it towards a particular main string, and then we have to find out. Okay, so as per our conditions, we have certain when there is a matching substring which is found, so that time we will be returning. Okay, that we will be having a match of the pattern has been found, and we'll be returning from that. But till that, we will be doing, we will be shifting the characters. So in this particular thing, okay, what is the main thing is we have some particular mechanism of forming a shift table. The shift table is nothing but the main process of input enhancement. So what is that is input enhancement? So instead of doing all the process in the algorithm, we do it and we process it and finish it, and we keep a table ready for the pattern matching in an easy step. That is how many times we have to shift, we will be getting it through that particular shift table. So we see the mechanisms which are involved here. So this is the horspool matching algorithm. Okay, I'll come to this algorithm after some time. Only after we know what we are going to do here, okay, we can go through the algorithm. So what we'll do is, see, we have to consider three main cases in horspool algorithm. The first case is that when when we are mapping a particular string with the, so here you can see, so this is nothing but the character string. So if you say a text string s0 to sn minus 1, so my string is barber, so I have to map this particular string with the particular string whatever is there. So in case I'm just mapping and I get a particular mapping, like I just keep the particular element and I check the last character with the character in the main string. So when I check there is a mismatch, means what will I do? I have to see the pattern length. Okay, so what is the pattern length? 1, 2, 3, 4, 5, 6 is the pattern length. So I will be shifting my pattern, okay, with, okay, in the, shifting my pattern is I have to map it towards that particular main string. So I will be doing it 6 times, okay, so that I bring it to the next character, that is the next character of the main string. So we have to know a proper example for this. So we'll just see that. So what is the next case? In the next case, if there are occurrences of the character C in the pattern, but it is not the last one there. So it's like, see, the pattern has a B value here and R is the last value. So when you map that, it is not equal. So in this case, what we see, there is no match. So what we'll do is, in this string, in the previous string, we didn't have any occurrence of the element here. Okay, so if you take S, is there any particular element which is occurring here? No. That's why we shifted it 6 times, because there is no match at all. We say that there is no match at all. So in that case, I have to shift it 6 times. I'm just going directly to my next phase. Okay, but here, when we see here, okay, I just map with R with B. And this is the character in the main string. So I will just check where this B is in my pattern string. So I can see here it is in the, okay, so this is the first position, second position, it is there. So how many times I have to shift my barber, okay, pattern? See, B has to be shifted here, then A has to be shifted here, like it has to go, like you're just moving the pattern to 2 characters, moving it to like this. Okay, so now it has come BAR, BER. Okay, so this is how we shift it. And the next condition, so in case I'm having a mapping like MER is there, that is the last pattern is matching, second pattern is also matching, second last is matching, but the next pattern is not matching. But you see here R is there. Okay, so check whether any element R is there here. Okay, it is not there. So surely this pattern also has to be shifted by the entire pattern's length. If in case I have an element here, that is R element in between here, you have to check the position and okay, you have to do the shifting. So that's what we see here in this particular case, where you have R mapping and okay, A is not matching, but you don't see A, you see R. The next occurrence of R is here. Okay, so how many characters? Okay, it is 1, 2 and 3. So what we will do, we will shift the characters 3. Okay, so in 3 positions we have shifted. So these are the cases which we are addressing. So what is that main thing? So when we are doing this pattern shifting, so how will we do it? We'll just see. So this is how we calculate the shift sizes, okay, for the shift table. So if you take a table, we are going to create a table. So for the pattern element, okay, how will you find out the shift size? It is being indicated here. Okay, so it's like it may be the pattern length M sometimes, that is only when C is not among the M-1 characters of the pattern. So that's what I told you. If C is there, that particular character, the last character is there in one of the particular positions, that time we will be shifting it, okay, in as per the particular shift table characteristic. So that is nothing but what is the distance of the character from the rightmost string. So what is that is what is here. See, M-1 characters of the pattern to its last character. So it's nothing but what is the value. Okay, so you have to find out what is the how it is placed. See how many how much distance between the last character and the particular character which is occurred in the characteristic. Okay, so here, so you can see in this particular example. So now I just explain this same example using my I'll just attach a particular video regarding this. So what is it? See, this is what is known as a shift table. So what is there in the shift table? Okay, so here what question they have given, you have to search the particular barber in the actual string. This is the actual string. Okay, so when we have to search this, how many shifts we have to do? Okay, we have to do the shifting of the barber text many times. Okay, so whenever we are doing the particular process, so what we need a shift table. So how this shift table is being created with all the alphabet characters. Okay, so why we are giving dashes? Because these characters are not there in the what do you say, in the pattern string. So these are the characters. We are just writing A, B, C, D, E, F, G till Z. Okay, so what is the actual algorithm? It tells that see, when there is no occurrence of the particular last character in the main, that is the pattern string, when it is not matching and there is no occurrence. So in that case, what we will do? We will be shifting the pattern totally in how many characters? Total length of the pattern string. So what is the total length of the pattern string? BAR. Okay, BAR. What is it? 6 is the pattern length. So As per this only we will be shifting for all other characters, because these characters are not there in the pattern string at all. So how will we find out this pattern strings thing? Okay, so if I take one particular so let me take see barber I'm taking. So what is this? See, we have how many characters? We have 6 characters. So in case I'm going to find out the occurrence of the shift table value for A. Okay, so how will I find out? See, this is the last character. Okay, from this last character, this is the first character. 1, 2, 3 and 4. So my A is 4 position away from my R. Okay, so you say 1, 2, 3, 4. So I'll just mark it as 4. And next B. See, when you take B, how many positions? Okay, we have to check. Okay, so first occurrence of B after this 1 and second position it is there. Okay, C. C is not there in my pattern string. So it is 6. And D, it is also not there. E is also, okay, E is there. It is in the next position of R. So it is only one position away. You can just write it like that only. And F, it is 6. And any other characters which are not there, okay, that is also 6. And R is also, okay, R, one more R is here, right? 1, 2, 3. So third position R is there. Then next, what is the other thing? See, these characters are not present in the string, so that is not considered. Then again Z is not there, and we have to include a underscore here, because many of the patterns, many of the characters will be having an underscore. So whenever we are generating a character shift table, we have to include this underscore also and write the value for it. So it will be the length of the pattern string. So how will we shift this particular Jim underscore saw me in a barber shop? Okay, so how will we do that? So what we do, we just take the pattern. So this is the pattern. I just took it and placed it under the particular main character string. Okay, text string. So what I do, I just match A and R. So A and R, when I match, what is happening? R is not matching with A. Okay, so in that case, I have to see anywhere A is there. Yeah, A is there. But before that, what we should see? We should see the shift table. Okay, so no need to see those things. Okay, no need to see where A is there, all those things. Just have to see the shift table. So it is nothing but it is giving the shift count as 4. So what I will do, I will move this particular barber by 4 positions. Okay, so 1, 2, 3 and 4. Now BAR has come here. And again, what will I do? I have to check R and E. So when I check R and E, is it matching? No. So what will I do? I will just see, okay, what is the shift table value for E? 1. So what I will do? I'll shift this barber by 1 position. Okay. So now what I did, I just moved this to the next position and I'm going to do the next. Okay. So this is nothing but the next step. Okay. So what we are doing now, we are coming to the last thing. And what is it? Underscore. Underscore, in underscore cases, what you should do? Move it to 6 positions. So after this, we are doing this step. Okay. So because we can't do it here below, we are doing it here. We can do it down also. It's just the passes whatever we are doing. So after this, what we do? Move it to 6 positions. It comes to this particular position. So after it comes to this position, what is the next thing? You have to match B and R. So B and R, are they matching? No. So anyway, just find out what is the value for B. It is 2. So I just shift B and A by 2, and now it is being shifted here. Okay. So again I will match R and R. Okay. But R and R is matching. Okay. I just match R and R means it is matching. But is the next characters matching? Okay. A and E, it is not matching. So what will I do? I have to check R. Okay. R's. Okay. So what is it here is, what is my R shift value? 3. Okay. So 1, 2 and 3. I come to the third position. So when I shifted only, I got my pattern match. Okay, so now when I match, this is also equal, 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 this is also. So now everything is matched. So did we go through the entire loop of the particular string? No, we just did the search, like, see, we did a shift, only a little number of shifts we have done. See how many steps you have done. 1, 2, 3, 4, 5, 6. In 6 steps, you have found out the pattern string. Okay, pattern match. So this is one particular easy method compared to the previous string matching methods, where we just compare every characters one by one. Okay, and do the particular process. So this is what we do here. So how do we manipulate this in an algorithm? Okay, so that is what we are seeing here. So what is the algorithm here? Okay, so what you will be doing in this algorithm? Okay, so what does a shift table contain? Shift table, it is nothing but, okay, you are telling it as a P array, which is having from 0 to m minus 1 elements. Okay, so it is going to fill the shift table with the pattern. This is nothing but alphabet of possible characters. That is, it has all A, B, C, D till the end with the pattern. Okay, how many shifts you need for the pattern, and the output is a table size which you should create with the alphabetic characters filled with the shift sizes computed by the formula. So how will you do it? 0 to size minus 1, that is the n minus 1 size, that is n minus 1 you can say, or okay, here it is m minus 1, or the size whatever is the table size. Okay, you are going to fill the table with the values, and similarly you are going to do this particular okay, pj, that is nothing but whatever be the pj values means this particular pattern is the next index, whatever we are using for the pattern string is j index. So this has to be filled with m minus 1 minus j, that is nothing but, see, till m minus 2 only you are doing that. You are not going to do the search for all the elements. See, you're going to stop it when you are getting a pattern match only. So we are going to do the shift table only till m minus 2. Okay, so it is m minus 1 minus j means, okay, so you take 0 to m minus 1. So m minus 1 is the value and minus j is the index whatever you are having. So as per the index only the value will be computed. So when you take the formula and calculate also, you will get the same value whatever you have done. It is nothing but the distance between the last character of the pattern and the occurrence of the particular j element in the particular thing. Okay, so when you subtract that particular value, you will be getting the position. So that is what is given as a formula here. Okay, so when you take horspool matching algorithm, so what they do in this, okay, so we are taking the pattern string in the text string. So what you do here, we have to take the shift table. Okay, so this is the shift table, right? So we will be generate the table shifts and keep it, and then we have to see the position. See, the position of the pattern's end will be m minus 1. So what we will be doing is we have to do the particular process, okay, till I less than n minus 1. So that is something where you have to go through the back side of the particular pattern string. So I told you, no, so you go from the right end of the pattern string till the left end of the pattern string, okay, and just check the elements of the match. Okay, so at this particular moment I will just start from the k index as 0. K is nothing but the pattern elements which are matching in the character string. So at the starting it is 0, but it will be going on. Okay, you have to keep on incrementing the values and finding out whether there is any pattern match. So that's what we do. While k is less than m minus 1, that is the pattern's last character, you're just going or equal to till this, you're going to go through the backside, and p of m minus 1 minus k, you're going to see this particular element, and you're going to keep on checking whether the element, okay, is matching, okay, as per the text. If a match happens, okay, so what you will do, you will tell that k is equal to m, right? That particular character, okay, that k value will be equal to m. So when it is equal to m, what you will be doing, you will be just going to the, okay, a match is being found, and when it is matched, you will be returning that particular position of the particular pattern, that is the first position of the pattern which is matched. So now you will be returning that. Or else what you have to do, you have to go to the next. What you have to do is you have to update the I value using the, okay, the table value, that is nothing but your shift table value will be there, no, as per that your index will be incremented and your shift will be done. So this is what is the shift part which is being done. And then or else, okay, so after this you will be returning minus 1 at the end. So till you get the particular output, you will be doing the particular process. So this is about the horspool algorithm. Okay, hope you understood. Okay, so what is the time complexity? Okay, so here when we take the worst case time complexity is order of nm, and for random text it is theta of n. So it is actually faster than the so when you see in random text it is only theta of n. So it is very faster than the brute force algorithm because it's not having a quadratic time complexity, it's just nm. Okay, it doesn't have any higher level of complexity. It is much better than the Boyer-Moore algorithm, okay, which we know that we have the North-Moore Pratt algorithm. Okay, so that is also one of the algorithm which we have learned. So it is much better than that algorithm. Okay, so this is what is about the horspool pattern matching algorithm. Okay, thank you.